Good morning, students. In this video, we are going to discuss about module number 4 of Computer Organization and Architecture, Memory System. Under this memory system topic, we are going to discuss about memory management. So let's see about the memory management in detail. So if you're going to see about memory management, an operating system is concerned with transferring the program and data between the secondary storage and the main memory. So as the operating system needs the memory routine in addition to the other routines, so obviously what happened, the operating system routines are assembled into a virtual address space called as system space. So this system space is a separate from the space in which the user application program is going to be reside. That is going to be called as an user space. So the virtual address space, which is going to be divided into two as one system space and another one is going to be several user spaces. So here if you're going to see about this particular diagram which have been shown over there, the memory management is going to be lying in between the device drivers and the CPU management. So let us see what actually a memory management is. A memory management is the process of controlling and coordinating the computer memory, assessing a portion which is going to be called as a block to a various running programs and to optimize the overall system performance. So this task, for example, if you're going to take a task that can be done manually by a programmer, or it can be automatically by the memory manager, which is going to be lying in the memory management system. So this is going to be called as a memory management system. It's nothing but controlling and coordinating the computer memory, that is going to be called as memory management. What actually the requirements of a particular memory management? So before entering into this requirement of memory management, let us see about what actually a memory management in a computer organization. So memory management is nothing but it's a form of a resource management which is applied to the computer memory. So the essential requirement of memory management is to provide ways to determine or dynamically allocate the portion of memory to a program at their request. So and free if or free the memory if it is reused or when no longer needed by the particular program. That is going to be actual memory management in the computer architecture. Let us see about the requirements of memory management. Memory management routines are part of the computer operating system. So as assembling the OS routine, operating system routine, into a virtual address space, that is going to be called as a system space. We have seen that one. And the virtual space in which the user application programs are going to be called as user space. So here each user space has a separate page table, and the memory management unit uses the page table to determine the address of the table to be used in the particular translation process. That is the main requirement of this memory management. Let us see some issues which are going to be there in the memory management. There are four issues are going to be there: relocation, protection, sharing, and efficiency. Let us see one by one. First one, relocation. What actually relocation is nothing but swapping of active process. So the swapping of active process in and out of the main memory to maximize the CPU utilization. So here the process may not be placed back in same main memory region, or the ability to relocate the process to different area of the memory, that is going to be called as relocation. Second one, protection. What actually a protection is going to be? Protection against unwanted interference. So a protection by another process, for example, the interference by another process must be ensured by the processor, maybe an hardware of the processor rather than the operating system. That is nothing but the protection. Third one, sharing. What actually sharing is? Flexibility to allow several processes. So allowing the several processes to access the same portion of the main memory, that is nothing but sharing of the memory in this particular memory management. Then fourth one, efficiency. Efficiency is going to be dealt with allocating for higher processes. There's nothing but the memory must be fairly allocated for a higher process utilization. The systematic flow of information between the main memory and secondary memory has to be taken care of over here. For that purpose, the allocation for higher process is going to be utilized over there. These are the 4 issues which is going to be coming under the memory management. Let us see about the next topic, memory management functions. What is the functions of memory management? So already we have come across over there the hierarchy of memory. So here the memory hierarchy has been shown over there. Always the topmost position registers are going to be there. Next to that, cache memory, 2 levels are going to be there, primary level cache memory and secondary level cache memory, L1 and L2. Both cache memories are going to be present in between the main memory and CPU register. And apart from that, the secondary memories are going to be present over there, as may be an magnetic tape or an optical memory or sequential access memories will be present over there. Let us see about the functions of memory management. A memory management unit, sometimes called paged memory management unit, PMMU, which is nothing but a computer hardware unit which having all memory references passed through itself. Primarily performing the translation of virtual memory address to physical address. The main memory management functions keeps tracking of the status of each memory location, either allocated or free, which is going to identify whether the memory has been allocated or still the memories are going to be free. That is going to be tracked by this particular memory management function. The next one, it determines how much memory is going to be allocated among the competing processes, and which is going to deciding which gets memory or when they receive it and how much they are allowed. Like that, it's going to determine the allocation. And the memory management unit, which is going to translate the logical or a virtual address into the physical addresses. And this memory management unit, which is going to use the content of page table base register to determine the address of the page table to be used in the translation. Example, changing the content of the page table base register can enable us to use a different page table and switch from one space to another. And even at a given time, the page table base register can point to one page table. Thus, only one page table can be used in the translation process at a given time, so that the pages belonging to only one space are accessible at any time, any given time. This is the function of the memory management unit. Let us see, when the process of the memory management process, we will see that when a multiple or an independent user program coexist in the main memory, how to ensure that one program does not modify or destroy the content of the other. How it's going to be possible. So the processor usually has 2 state of operation. One is going to be called as user state, one more is going to be called as supervisory state. What actually is going to do that one? In the user state, user programs are executed. Certain privileges instructions cannot be executed in the user state, because this privileged instructions include the ones which change the page table base register. Hence, prevents one user from accessing the space of the other user also, so that the user state is going to be, doesn't have the privileged instruction execution. Whereas the supervisory state, operating system routines are going to be executed. Hence, the supervisory state, it's going to do the routines which is going to be present in the operating system. Such a way, we are going to overcome this multiple or independent user program coexist in the main memory, and it cannot be modified or destroyed from any of the user space. Such a way, these 2 stages are going to be helpful for us to do the particular operation or the memory management process. Let us see about privilege instruction. What actually the privilege instructions are going to be. In user state, what happened? The machine instruction which cannot be executed. Hence, an user program is prevented from accessing the page table or page table of the system spaces. Hence, what happened? The control bit in each entry can be sent to a control the access privileged granted to each program, okay, which have been guaranteed by the privileges. So that what happened, one program may not be allowed to read as well as write a given page. so that any one function will be get performed, so that a multiple independent user program can coexist, and it will not modify or destroy the content of this other one. So while the other program may be given only a read access or a write access, such a process is going to be taken care by the memory management, so that it's going to overcome the problem of modifying or destroying of the other content when a multiple or any multiple independent users are going to exist in the particular main memory.